So we're back again, and we have another problem here. This time we have this fourth degree polynomial, and we are asked to find all the zeros given that 2 plus I is a 0. Okay. Now let me just show you this off to the side here. We have the conjugate theorem. The conjugate theorem basically says that if a plus bi is a 0, then its conjugate a minus bi must also be a 0. So where does that apply? Well, since they tell us that 2 plus I is a 0, we know right away that 2 minus I is also a 0. That's it. That's the only new piece of information that we have based on the theorem that we were just given. So let's go ahead and go through this problem. It's a little bit tedious, but the process is the same as all the others. We're going to divide by the 0 that we're given. So 2 plus I, and we're not missing terms, so we'll do 1, -1, -17, 55, and -50. Okay, and whenever you're dividing by a complex 0, it's a good idea to leave a little bit of space between your coefficients, maybe more space than I did right here, right? But the more space you can leave, the better, because each one of these numbers in the next row is going to have 2 terms. Okay. So first up, we take this 1 here and bring it down. And then we do 1 times 2 plus I. It's pretty easy. That's just 2 plus I. And then we add here. Since this one has a real part and this one, or rather, this one has an imaginary part and this one doesn't, we just add up the real parts and add them. So we end up with 1 plus I. Okay, now is the kind of tedious part, right? We have to multiply. So we'll come down here and we'll multiply 2 plus I times 1 plus I. So 2 times 1 is 2. 2 times I is 2I. 1 times I is I, and I times I is I squared. So then 2 plus 3I plus I squared, hey, that's -1. So -1 is the product. And -1 plus 2 is a 1. So we have 1 plus 3I. So guess what? We add again. -17 plus 1 is -16 plus 3I. And we multiply again. So this time 2 plus 3I times -16 plus 3I. So 2 times -16 is -32. 2 times 3I is 6I. I times -16 is -16I. And I times 3I is 3I squared. So then we have -32 minus 10I, and then I squared is -1. That makes this whole thing minus 3. And then combining like terms, we end up with -35 minus 10I. So that goes there. And then we add. So 55 minus 35 is 20 minus 10I. And so we do this multiplication one last time, and we know that we've done the problem correctly if we end up with the 0 as a remainder, because we were told that 2 plus I is a 0. So let's go through this multiplication one more time. So 2 plus I times 20 minus 10I. Okay, 2 times 20 is a 40. 2 times -10 is a -20. I, right? 2 times -10I. And then I times 20 is plus 20I. And then I times 10I, -10I is -10I squared. So now look at the -20I and the 20I, they cancel. And then -10I squared, again, since I squared is -1, becomes +10. and we have this 40 here. So that result is 50. So 50. And look, negative 50 plus 50 is a 0. Okay. So we just divided through by the 0 that we were given, and we get this relatively ugly polynomial, right? I call it ugly because it has complex coefficients, right? The coefficients have i's in them. But let's keep in mind where we are. We had a 4th degree polynomial, and we divided, right? So then the result must be a 3rd degree. The degree is still a little bit too high for us to use any of the tools that we want to use, like the quadratic formula or factoring. So then we need to divide one more time. So we'll take this result, 1 plus I, negative 16 plus 3I, and 20 minus 10I, and divide by something else that we know is a 0. And what else do we know is a 0? Well, 2 minus I. Now this looks like it should concern us. But the good news is, I'll tell you in advance, all these i's are going to end up canceling. So let's see. First we'll bring down this 1, and then we multiply by 1. So 2 minus I. That's what we get, because we distribute a 1. Now we add 1 plus 2 is 3, and just like we promised, the i's cancel. So then we do it again. We multiply by 3, right? And when I say multiply by 3, I'm saying distribute. So 3 times 2 is 6. And then 3 times negative I is negative 3I. And so look, the 3i's cancel. And negative 16 plus 6 is negative 10. And then we do it again. Negative 10 times 2 is negative 20, and negative 10 times negative I is a plus a 10i. So then these cancel. Look at that. We knew the remainder had to be 0 because, again, we said that 2 minus I is a 0. Okay, and we've gone from x to the 4th up here to x cubed right here. And since we divided by that cubic, or divided that cubic, now what we have left is a quadratic. So what we did in the previous problem is we took the quadratic, set it equal to 0, and solved, right? You can use whatever method you like, but let's use the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Underneath this radical here, we get a 49. All over 2. So that's 3 plus 7, because the square root of 49 is 7. Negative 3 plus 7, that is a 4 over 2. And then the next one here, negative 3 minus 7, that's negative 10 over 2. So then we have 2, negative 5. Oops, hit my head there. So those are the last two zeros. Let me highlight all the zeros that we have, or circle them. Okay, so the first 0 is the one we were given, 2 plus I. The second 0 is the one that we kind of deduced, must be 2 minus I. And then we use the quadratic formula to find the last 2. 2 and negative 5. Okay. And because our polynomial was a degree 4 polynomial, we know that's all the zeros that we can have. 1, 2, 3, 4. And we are done. Way to go.